Alright, in this video we're going to address one tiny thing we need to stack onto the PFD concept we built up in the part 1 video. Just a little unpleasant occurrence that we're going to have to take into account too. Basically, we're going to investigate what happens when the part 3 step of PFD is not very nice. That is, we won't be able to plug in, for instance, like a specific value of x that will eliminate A, C, D, and E, but leave B okay. There are a lot of PFD problems in which there are just so many of these A, B, C variables that it's nearly impossible to plug in a value of x that will eliminate all of these variables except for one of them. So we're going to talk about what to do in these cases. Alright, so take this PFD problem right there. Step 0 wasn't needed. We didn't have to do long division. We did our split here. A over x. We have this first version of a quadratic equation, and we had the second version of that quadratic equation, x squared plus 1. And then after that, we multiplied both sides of this equation by our denominator. And when the dust settled, we got here. So the problem that we're really focusing on in this video occurs at the step 3 of PFD. So we'll just focus on this. Alright, so if I'm following the PFD step 3 that we built up in the last video, what I want to do is I want to try to figure out what my A is first, which means I need to figure out some value to plug in for x such that it eliminates B, C, D, and E, but leaves A okay, so that I can solve for what A is equal to. And I'm always looking at my coefficients here. I'm thinking about, alright, what values can I plug in for x that will basically turn, one of these factors to 0, so that it completely annihilates this guy and this guy, but will at the same time not eliminate A. And I see that if I plug in x as 0, that will eliminate this dx plus e factor and this bx plus c factor, but also it'll leave this a okay. That'll just be 0 squared plus 1 is 1, 1 squared is just 1, 1 times a is just a. So it looks like all is going well so far. If I want to solve for a, I can just plug in 0 in for my x's. And if I do that, if I plug in 0 for all of my x's, I will be left with this following expression. And we can see that a will equal 1, no problem. So at this point, I'm gonna put a 1 in for that a. A is not an unknown anymore. I'm not going to put a there anymore. I'm just going to put 1 because we know what that a is. So now here's where the problems arise. I want to plug in a value for x such that I can eliminate C, D, and E, but leave B okay, so I can solve for it. And notice that I don't really care about A anymore because A is just 1. It's a value, it's not unknown, I'm not even worrying about it anymore. But if you're really looking at this thing, there's really no way to do that. I mean, I might think about plugging in 0 in for x here. That would eliminate this. But don't forget, doing that will also eliminate the whole bx plus c, and there goes my b. So, long story short, there's no x value that you can plug in that will allow you to eliminate all of my unknown letters except for b. It's just not possible. So, what to do in these situations is the subject of this video. Unfortunately, we're going to have to launch into this brute force mathematical procedure that's going to take a little bit of time and patience, but it will get us to figuring out what B, C, D, and E are. Alright, so all these steps that we're about to go through pertain to the right-hand side of this equation right here. So, and the first step is we want to multiply everything. So you want to FOIL in the 1 in here, you want to FOIL all this stuff together, that's going to be nasty. We're going to want to FOIL in the x in here. We're just going to multiply everything on that right-hand side. Alright, so I expanded my square here. I did this foiling right here, but I still have to do the foiling of these two. And I did that foiling, that wasn't too bad. Alright, so let me just FOIL these guys together now. Alright, so there we go. Alright, and that completes step 1. So I'm just going to bring all this stuff up here a bit. Alright, so my second step is to group the terms with the same powers. I want to put all these terms together. So notice how I have some terms with x to the 4th. Here's one, here's another one. I'm going to want to put them all together. I'll have, looks like just one term with an x cubed. I want to put them together. I have a whole bunch of terms with x squared. So I want to put them together, and so on and so forth. So I'll put my x to the 4th terms in blue. Here's one, here's the other one. I'll put my x cubed terms in green. Here's the only one. I'll put my x squared terms in orange. Here's one, here's another one, here's another one right there. Of course, I could have some x to the 1 terms. Looks like I have 2 of them, here and here. And it looks like I have one x to the 0 term. This one right here. In effect, this 1 is getting multiplied by an x to the 0, because x to the 0 is just 1. So any terms that are just by themselves, that have no x attached to it, are basically these x to the 0 terms. Alright, so looks like we have completed step 2. Of course, we don't want to forget that there's something on the left-hand side of this equal sign. Alright, step 3. Alright, step 3 isn't too bad. We're just going to factor out the powers from the work we've already done. So for my x to the 4th terms, I'll just factor out the x to the 4th. And I'll get this. And I'll just do this down the line. So now I have this. So now we want to equalize the coefficients. So remember, we have this big right-hand side of our equation, and it's equal to this left-hand side of the equation. They're equal to each other. They should look the same. This left-hand side has an x cubed, this right-hand side has an x cubed. This left-hand side has an x squared, so does this right-hand side. And so on and so forth. So if the coefficient of the x cubed on my left-hand side is -1, well, that has to be equal to the coefficient of the x cubed on the right-hand side of my equation. What this tells me is -1 is equal to c. Well, that was easy. Well, let's look at our x squared term. So the coefficient of the x squared on the left-hand side of the equation is 2, and we know that must exactly match the coefficient of the x squared term on the right-hand side of the equation. So what this is telling us is that 2 must be equal to this whole thing, 2 plus b plus d. So that's what equalizing the coefficients mean. On the left-hand side, the coefficient of my x to the 1 term is -1. And on the right-hand side, the coefficient of the x to the 1 is cs plus e. So I get -1, and c plus e must be the same thing. If I look at my x to the 0 terms, I just get a 1 is equal to 1, which isn't really helpful, so I'll just ignore that. Now I haven't talked about my x to the 4th term. It's a tiny bit confusing because you may look at that left-hand side and say, hey, there's no x to the 4th term, but there actually is. It's just 0 times x to the 4th. Kind of tricky. So in that light, the coefficient of the x to the 4th term on the left-hand side is a 0, and we know that must be equal to the coefficient of the x to the 4th term on the right-hand side, which is a b plus 1. So I have now completed step 4, equalize the coefficients. I equalized the coefficients on the left-hand side to the coefficients on the right-hand side. So step 5, all I have to do is solve this system of equations right here. And if you look at it, it's not exactly too bad. We already know c is -1. I'm sure we could exploit that fact. Right here I can put in -1, which means that e will equal 0. Looking at this guy right here, it's pretty easy to see that b will equal -1. And now that we know that, I can go to my yellow-orange equation. If b is -1, I can solve for d pretty easily, and d will equal 1. And there we go. I have solved the system of equations, and I know a, b, c, d, and e. Now, I hate to say this, but sometimes that resulting system of equations won't be as nice to us. I mean, we were able to look at this system of equations and just kind of roll with it. We didn't have to do I didn't have to like substitute this equation, that equation, or anything like that. I kind of just, things just kind of unlocked for me pretty easily. But of course, some systems of equations, this won't be the case. And you can either solve it by hand, or you can put it into a matrix and let, a calculator do it for you. And if you want to learn that matrix technique for solving a system of equations, I have a video on that. I suggest this because it is a lot faster than having to solve some system of equations by hand. And when you get into your later engineering courses, you're going to be asked to analyze these really big systems. It could be a huge circuit or a huge truss. And you'll have a lot of equations, a lot of unknowns, and you will really, the only practical way of solving that system is to just use the matrix technique. So I highly recommend learning up on that technique. But that is it. Now that we know A, B, C, D, and E, we can proceed with the partial fraction decomposition technique that we went over in the previous video. So just watch out, because in some PFD problems, that step 3, figuring out your unknowns, is not as easy as I told you in the last video. Sometimes there's just too many unknowns just to be able to put in one value of x and eliminate all of the unknowns except for one. So in those cases, you're going to have to execute these steps here. It's a bit annoying, it's a bit tedious, but it will definitely get you those unknowns.